Good morning. Today we are going to discuss about the standard hydrogen electrode. The standard hydrogen electrode acts as a primary reference electrode. For using, we can find out the EMF of the cell. It is impossible to determine the absolute value of single electrode potential, but we can measure the potential difference between two electrodes by potentiometrically. For that purpose, we can use one reference electrode, that is primary reference electrode. Example, standard hydrogen electrode. Why reference electrodes matter? Voltage differences. Electrochemical cell measure voltage differences between two electrodes requiring a stable reference point for accurate comparison. One acts as an anode, another electrode acts as a cathode. So we can calculate the EMF of the cell by using formula E cell equal to E right minus E left. So known reference, a stable known reference potential is essential to compare and calculate half cell potential in any electrochemical system. Universal scale. The standard hydrogen electrode defines zero voltage and storing the entire electrochemical potential scale worldwide. What is the standard hydrogen electrode? This is the standard hydrogen electrode picture. In this, SKC is a half cell consisting of hydrogen gas at 1 bar pressure bubbling over a platinized platinum electrode immersed in 0.1 molar concentration of HCl solution. So half reaction gives 2H plus 2 electrons gives hydrogen molecule. By definition, the SKC potential value is 0 volt at all temperature. So this is the universal primary reference electrode. Then the anatomy of the SKC. First one is platinized platinum electrode, inert material with excellent conductivity that catalyzes hydrogen redox reactions without participating in the chemistry. Then acidic solution. Hydrochloric acid is a strong electrolyte, acidic solution. So hydrogen plus activity maintained at 1 molar per liter to ensure standard conditions and consistent electrode behavior. Then hydrogen gas flow, continuously bubbled at 1 atmospheric pressure to maintain equilibrium and provide reproducible potential. Then the chemistry behind SHC operation. Ion reduction. Hydrogen ions gain electrons at the platinum surface, forming absorbed hydrogen atoms through electrochemical reduction reactions. Then atom combination. Adsorbed hydrogen atoms combine to form molecular hydrogen, which are then released from the electrode surface. Then dynamic equilibrium. The equilibrium between H plus ions, electrons and hydrogen gas defines the electrode potential under standard condition. Then practical challenges of using SHC. Gas handling. Requires continuously hydrogen gas bubbling at 1 atmospheric pressure, creating safety and handling complication in laboratory settings. Then slow kinetics. Electrode reactions proceed slowly, making measurements time-consuming and requiring potentials for equilibrium. Maintenance issues. Difficult to maintain constant pressure and pure conditions over extended measurement periods. Then portability limits. Not portable, severely limiting routine laboratory and field applications. Then practical alternatives inspired by SHC. Saturated calomel electrode. This is an example for secondary reference electrode. SHC acts as a primary reference, as SCE acts as a secondary reference electrode. Then secondary reference electrode example calomel electrode is represented by mercury/mercurous chloride system that is easier to handle with stable potential value is positive to 0.241 volt. SKC acts as a reference primary, electrode potential value is 0 volt. Then silver chloride system that's stable and widely used, providing plus 0.197 voltage versus SKC acts as a reference. Then palladium hydrogen absorbs hydrogen directly, eliminating gas bubbling needs with plus 50 millivolt versus SKC act as a primary reference. Then fundamental standard SKC remains the absolute reference defining all electrode potentials in electrochemical science. Global consistency enables consistent, comparable electrochemical measurements across laboratories worldwide. Then scientific precision simplifies the precision and the rigor that defines modern electrochemical science. Then heartbeat of electrochemistry is mainly absolute reference, universal understanding, practical inspiration, 0 volt benchmark. Thank you.